fundamental principle of counting. Okay. So let's talk basically about how do we count how many number of things we have based on some of the conditions that are given. Okay, so that just sounded very confusing. Let me give an example. Okay, so let's say you have 4 shirts. Okay, and you have four different shirts. Okay, I should say different. 4 different shirts, and let's say you have 5 different like jeans. Okay, and you're trying to pick out. They're all different. They're slightly different style, so you're trying to pick out which ones to wear, which combination to wear today. Okay, and so how many different possibilities are there? That's what you're concerned about. Let's say you like them all. None of them are old. None of them are something that you want to throw away. They're fantastic. You just bought them yesterday. Okay, so how many different combinations do you have to go out with your friends? Okay, and so how do you count something like that, right? And this is how you do that. You have shirt 1, right? So if you pick the shirt 1, right?
Mm-hmm.
How many choices do you have for pants afterwards?
5.
Right, that's very obvious, right? So jean 1, jean 2, jean 3, and jean 4, and jean 5, right? But you could do this for every single shirt.
Mm-hmm.
You could do this for shirt 2, and the choices of jeans doesn't change, right?
No.
Okay. So this is now shirt 3 and shirt 4, same type of choices, right?
Mm-hmm.
So looking at this tree chart, you can see that the number of choices you have is, first of all, you have 4 shirts. For every shirt, right, you have 5 jeans, right? So that's 4 times 5.
Okay.
Okay, so if that 4 times 5 was a little bit quick, think about how to, we can do this. Shirt 1, right? Shirt 1, shirt 2, shirt 3, shirt 4, right? Okay, and then we compare shirt 1 with different jeans, right?
Mm-hmm.
So different jean 1, jean 2, jean 3, jean 4, jean 5, right? So look, do you see shirt 1? So shirt 1, S1, and jean 1, that represents this first branch here.
Yeah.
Okay, and then the second column here can represent shirt 1 still, but jean 2, right?
Mm-hmm.
And so on, all the way up to shirt 1 and up to jean 5, right? All the way down to, this is going to be shirt 4, jean 1, right?
Mm-hmm.
All the way up to, this is going to be still shirt 4, because we're still in the last row, but jean 5, right? How many brackets do I have in this box here? It's clearly 4 times by 5, right? Okay, 4 times by 5. So we just ended up multiplying the two numbers, right?
Mm-hmm.
So if you have, for a certain choice, so if you want to select different ways of doing things, right? And you're given two, this is essentially the first, we call it the first phase.
Mm-hmm.
So it's a phase because picking a shirt and picking a jeans is a separate process, right? You don't put you don't wear on top like your jeans, right?
Yeah.
You don't put your arm through the jeans.
Yeah.
So this is the first phase, and then we call this a second phase. Okay. So what the fundamental theorem of counting tells us is that to count all the different ways of doing things, you count. So to count the total number of ways of doing things, you just count the number of ways of first phase times by, right, number of ways of the second phase. Okay, and if there's more phases, for example, now you have different socks or hats or earrings, you just keep multiplying them.
Okay.
Okay, so that's how we count things. Okay, so let's do a simple example. Okay, let's do a very simple example. Let's say we have the letter A, B, C, D. Right. And I want to know how many different ways I can rearrange, okay? Rearrange these letters A, B, C, D. Okay? Now, so that basically boils down to picking letters for 4 different spots. So this is your first spot, second, third, and fourth. And these are what I mean by phases. So you pick, this is your phase 1. So how many choices do you have for phase 1?
You have 4.
Right? Because you can pick A, B, or C, or D, right? Okay, so 4. Okay, and then once you pick the first one, right? How many choices do you have for the second one?
3.
3. Right? Because you use one up, right?
Yeah.
And it could be, again, the tree makes a lot of sense. It could be A, B, or C, or D. But it doesn't matter. Whatever you picked, that's gone. Afterwards, you have 3 choices. Right? So then you pick another one. Let's say you pick B this time, right? If that's gone, you still have, and for all 3, right? You have 2 more choices, right? So times by 2, and then after that, it's 1 choices. Okay, so this process is called the fundamental principle of counting. Okay, so if you don't use this, broken down step-by-step process, and you try to sort of imagine in your mind, visualize 4 shirts with 5 jeans. It's kind of difficult, especially if I give you more. Like, let's say you bought like 10 nice shirts and 12 different jeans, and then you have like 7 different hats, and then you have like 6 different types of makeup. Like, it just gets really complicated how many choices you have, right? But just having 10 different shirts, having 10 different jeans, having 10 different makeup, counting those individually is easy. So you just multiply through them, and then you get all possibilities. Is that okay? Okay, so that's fundamental principle of counting. Let's do some more examples.